Hi, my name is Ian Tam, and I'm a sophomore at Jericho High School in New York. I live with my parents, my grandmother, my older brother, and my younger sister. Outside of school, I enjoy traveling, playing the cello, watching soccer, and playing volleyball. I am a huge fan of Manchester United FC, and one of the most memorable experiences for me was watching them play live. I also enjoy flying drones, especially while traveling. In Iceland, I use my drone to capture images and videos of glaciers, waterfalls, and natural landscapes. Seeing those environments from above and documenting them was an unforgettable experience. I've always been curious about engineering starting from a young age. It all began when I was 7 years old and when I traveled to Japan. Over there, I saw the Shinkansen for the first time. I remember being amazed by how fast and smooth it was, and how something so large can move in a perfect manner. At that age, I did not understand how it worked, but it made me very curious. I began wondering how engineers design machines that can operate with that level of precision and reliability. As my curiosity grew, I became especially fascinated by flight. Whenever I flew on a plane, I would always ask the pilots if I could see the cockpit. Over time, I had multiple opportunities to step inside and observe the controls and instruments up close. Seeing how everything worked together to operate such a complex machine made a lasting impression on me. I also visited the Intrepid Museum, where I was able to see real aircraft on the flight deck. Being able to observe these machines in person gave me a deeper understanding and appreciation for aerospace engineering. My interest grew even further when I visited Kennedy Space Center and saw my first rocket launch. Watching the rocket lift off in person after seeing it online so many times was an unforgettable experience. To experience aerospace more directly, I joined Civil Air Patrol, where I had the opportunity to experience flight firsthand. Through orientation flights in Cessna aircraft, I was able to take control of the plane and observe how it responded to different control inputs. It was incredible to see how small adjustments to the yoke could affect the aircraft's motion and stability. Being in the cockpit gave me a better understanding of how pilots interact with flight systems and how engineering, control, and feedback all work together in real world conditions. Civil Air Patrol has also taught me discipline, responsibility, and teamwork. We trained together and learned how aviation operations depend on preparation, coordination, and clear communication. This experience gave me first-hand exposure to aerospace systems and deepened my interest in aviation and engineering alike.
In 7th grade, I joined a VEX robotics team, where I learned about robotic programming and design.
Over time, I became co-captain and lead programmer, responsible for developing the control software and coordinating our autonomous strategy. We worked together to integrate mechanical, electrical, and software components into a reliable system. We used odometry using encoder feedback and inertial sensors, allowing the robot to estimate its position and orientation in real time. Using this positional data, we designed autonomous trajectories and used boomerang controllers to guide the robot smoothly to target positions, continuously correcting for position and heading error. Developing these systems required extensive testing and iteration. We documented our design decisions, testing results, and improvements in our engineering notebook, allowing us to track progress, identify sources of error, and refine our approach over time. Through collaboration, technical development, and systematic documentation, our team has won more than 14 awards, became state semifinalists, and competed at the VEX Robotics World Championship.
Continuing on my curiosity in STEM, I joined my high school's science research program, where I began working on independent engineering projects. One of my main projects I worked on was HydroWind AI, where, together with the team, we developed an app that uses artificial intelligence and geospatial data to identify optimal offshore wind farm locations. Alongside this, we designed a novel offshore wind turbine using CAD modeling and engineering principles to explore how turbine structures could better adapt to harsh offshore conditions. We also completed a research paper documenting our design and analyses. We presented this project in the Samsung Solve Tomorrow competition, where we received the Promising STEM Innovation and $1,000 in funding for our research program. In addition, I am currently researching UAV systems, studying how drones maintain stability and respond to changes in motor output and environmental conditions. Through these experiences, I will continue to apply engineering and research to explore aerospace and autonomous systems. Through Civil Air Patrol, robotics, and science research competitions, I've gained hands on experience working in teams to design, test, and improve engineering systems. These experiences taught me how to solve problems, learn from failure, and work together to build reliable solutions. Seas represents an incredible opportunity to apply these skills in a real NASA research environment and contribute to meaningful aerospace projects. I'm excited to continue building, learning, and contributing to the future of aerospace engineering. Thank you so much for watching.